let's see. Good morning, everyone.
Okay, when you plug in, I'm just going to give a short introduction.
All right.
Luis is a software engineer who also loves to share his thoughts about quality, tests, and object-oriented programming. Active member of the PHP community and contributor to open source projects. He'll try to decompose a live application with confidence, as we said. All set, Luis?
Not yet.
Okay, the floor is yours. Enjoy.
Thank you.
Okay.
Should be good now. Yeah. Awesome. Good morning. Thank you for coming here to my talk. It is a true pleasure to be here, and this venue is awesome, isn't it? I forgot to plug this, and you can see that I'm a little intimidated. So, we're here to talk about confidence. And I need to do a very important question for you. Who of you, please raise your hands, who of you don't remember when was the last time you take some days off or vacations? Just let me, yeah. So I used to be just like that, and I must say that there's nothing better than some days off to boost up your confidence, and it will be really good. And the last time I took some days off was last week, and I visited Italy. So I went to PHP Day in Verona, and I stayed for a couple days more, traveling around the north of Italy. And I saw a city, I visited a city called Bassano del Grappa. I don't know if you've been there, but it has this amazing bridge. And it has so much history there. The bridge itself is really, really, really old. And it was redesigned around 1569. And so you can tell that it fell apart many times. It survived during many things. But the last time it was completely destroyed was during the Second World War. And if you go there, on the buildings around, you'll see the bullet holes like from the battles that were fought there. And it's really amazing. And nowadays, the building is, the bridge is being reformed. There is some construction work because of some structural damages. And if you go there, you can see this kind of things lying around. So these are patches that people are doing to ensure that the bridge doesn't fall. When I saw that together with my friends, we said, hey, this is a software. This is the best representation for a live software. It has history, context, it has a utility, like people cross that to get to the other side, and it's used every single day. And by the way, there we are, software engineers trying to patch everything around there. So my name is Luis Cobucci. I am from Brazil. I'm living here in the Netherlands for about 2.5 years. And I need to share some things with you about myself. I'm very, how can I describe this? I'm very, not really pragmatic, but I try to be pragmatic, but I really like to have everything working and up to certain standards. So perfectionist by a lot, but I can be flexible as well. And you'll see that I exaggerate a lot on the things that I will, the stories that I will share with you. So I work now at Usabilla. It's a company that essentially help other companies to improve by providing ways to collect and analyze feedback from their customers. And when I started there about 1.5 years ago, I saw this kind of pattern, and I think you're all familiar with that. It is like completely chaos. Everything was just like this. And you couldn't be confident about what you're doing because there were no tests. And actually, there were some small test coverage happening there on some classes, but they were not covering the important parts of the application. We had an outdated stacks, so outdated database version, outdated PHP version, outdated framework version, outdated libraries. Everything was hard to update because of the complexity that we had to have there. We put a lot of, we coupled a lot of things to the libraries and frameworks, and this is not a very good decision to make, and that was causing us to be very slow to react to the changes. And this is not good for a company, you can imagine, because you cannot deliver to your clients, which means that for us, we had this release cycle, which on every 3 weeks, we deployed to production. And you know what happens when you have this kind of things? Bugs. We had a lot of bugs because of the complexity, lack of testing, and a long time to get to the customers. And the curious thing is, when we created something, we did a change in a module, we broke a module like in the other side of the software, completely apart from everything. But there was still some light there. We had very good people at Usabilla. And these people, although they were quite young in the company, they were very motivated to organize everything. And there was already a lot of work in progress happening there to improve the culture of the company, to ensure that everything is being worked using or following some standards. And so we decided, hey, we have this big monster. Let's refactor everything. You know how it goes. We didn't manage to refactor all the things, but we managed to do very good work. We increased the test coverage from 0 to 25%, which is not huge, but, well, given the context, is a lot. However, do you remember that Italian breach that I spoke about? So, in the middle of this refactoring process, we realized that we were not dealing with one Italian breach, but rather 6. And then you say, like, what? How is this even possible? So, like every company in the world, Usabilla grew, right? So it started very small with a very limited set of features. We are a feedback company, and we were collecting feedback from a specific channel. When we decided to explore new channels, we said, okay, we already have something working here. Let's copy and paste, move it there, and change. We apply the changes that we need to do for this specific project, and we deliver. We have happy clients, and everything is good. Then we did that again, then again, then again, and each product evolved in different ways. So right now we have many different features only available in one product, for example, and not on the others. The interface of some products are completely terrible, where others are more modern. You can easily see your feedback data. We found ourselves in this big ball of mud, and we were just sitting there. What can we do? Because we are still very slow, and the company still needs a lot of features, but we can't deliver. What can we do? We had to take a very bold move and say, okay, we need to unify this thing. But this unification, we cannot do one thing, which is a very big rewrite. I don't know if you ever had to deal with this kind of thing, but there is a very well-established pattern to deal with this, which is the Strangler pattern. The idea is that, I don't know if you ever saw this kind of vine, but it grows around the trees from the top, and then it starts to consume or drain the life of the tree. And it grows, gets to the root. And eventually, the tree itself cannot do anything else. And it dies because, well, there's no nutrients to get and to have life. But the vine survives. And the Strangler pattern is pretty much the same. So we have this big, scary application there that we are afraid to touch. The first thing we do to start changing things is, let's put a proxy in front of something. And that proxy, for now, won't do anything. It will just keep sending the request to the same place. Then we start to create something new, something nice and shiny. Once this is created and you deploy this to production, in a production live environment, you start to run some manual tests or automated tests to ensure that in that specific environment, this new and shiny application still works. Once you validated that, you start to send traffic to this new and shiny thing. Let's say that this new application is only getting requests from, and it was only built for one specific endpoint. You have an API, and just one resource is going to that. You're not going to send all the traffic to that new thing. You should send just 10% or 5%, just so you can monitor things. And based on the feedback from your monitoring and your metrics, you'll see if everything is good or not. If things are good, you're going to say, hey, move everything. And you can, from here, just say, hey, I want to evolve this nice and shiny thing, or you can also create new services. And it follows the same pattern. You create something new, you test, you pass the route, and it is available there. New service, route there. Eventually, the big and scary application won't have anything else going there. And it just dies. This is really amazing, and you can say like, wow, I want to have that in my software because I can evolve things and create things around until I get this this state where everything is clean, right? But this was not applicable for us. Remember, we have 6 different bridges. And in every single bridge, we cannot just say, hey, this specific part of this endpoint will go to the nice and shiny thing, do the same on the other one, because it's not only about the resources, but also about the schema of the data. So because each product evolves separately, the data that we were storing for product A was completely different from product B. and C, and D, and so it goes. So we really needed to say, hey, let's try to rewrite this, but in a different way. Let's try to use this decomposition thing where we can extract some logic from this specific place and put it there, test it, and eventually we will make it available to the clients. But there are things that we need to discuss here. I don't know if you ever saw this quote. This is from Domain-Driven Design Distilled, which is a very good book. And it gets to two big points. This is in the very beginning of the book. And the first chapter talks about the thing about no design. And Vault essentially says that there's no such thing as no design. You can either have a good or effective design or a really bad design. And we already know the bad design. We already have, we are experiencing the problems of having a bad design. So we need to think. And this was not really good for us because we didn't have much time. We started this project around, well, the discussion started in around November of last year, and the implementations, we were giving essentially 2 or 3 months to implement this new thing, which is a very short time because there are many discussions that we need to do. Because everyone in the company didn't know of the domain. Like the product owners, they were not 100% part of what we had there. They knew what we want to have in the future, but how things work and behave in the current scenario was something mysterious for most of people. We said, hey, we need help here. We called a consultant in, a very good one, Marian, and from DDD and L. He organizes the meetups around there. And we started to do this thing about event storming, just to understand what are the events that happens in the system that we have, and what are the consequences, and what are the triggers of these events. You can see that here is really chaotic, but the idea of event storming is really nice. And once you manage to get everybody in the same place, you'll see, like, it's easy to code based on the events and commands that you have there. After doing those event storming sessions, we went for context mapping sessions, where we have something more aligned to how we want to understand the domain, what are the concepts inside there. Not that the event storming doesn't give that input. We can have the aggregates information there as well. But now we want to know a bit more of what's around the aggregate, what's in there, how do we tackle this. And this was the mapping. You can see all the exclamation marks there. Every single thing there is one of the projects that created a new life and a new model. This was really interesting for us to visualize, hey, we really messed up here. Let's start from scratch. And by doing these explorations and discussing things with the team, we managed to even have a PO that was writing Gherkin scenarios from everything that we had. She was absolutely fantastic. She just submitted pull requests to our projects and just saying, hey, this is a feature that we need to implement. These are the scenarios. This is the behavior. Let's refine on the pull request level, and let's see how it goes. then eventually it gets implemented. But the clarity that the domain explorations and the using Gherkin gave us to implement these things that we started to decompose was really good. Then we said, hey, okay, let's define some standards that we need to match. And let's create metrics around some things. We defined some service level indicators and service level objectives. So indicators are just data that are essentially metrics that we want to measure, like, hey, what is the response time of this specific task? Or how long does it take from process A to process C? The objectives is more aligned with, hey, we want to ensure that the response time is under X milliseconds, under this concurrency level, right? If you are going to DPC, Rafael Doms, he will give a talk about only how we managed to do the metrics using Prometheus and how we integrated that into the system. And we said, hey, we need some sort of service-oriented architecture. There's a lot of discussion on, hey, is this bad? Is this good? Should we use it or not? Usually, you don't need to use. A monolith does the task, most of times. For us, using this kind of architecture allows us to evolve the services. So we could have a service being deployed, already deployed there and running, and deploys a new version of it right next to it without doing anything here, and just new clients starting to migrate to the new structure of this specific service. And eventually, when this service is not used anymore, it just dies, right? But there are some discussions that you have to do when you're discussing, when you're thinking about, hey, should I use service-oriented architecture or microservices? And I think the most complex one is, how are we going to deploy this? How are we going to ensure that it is reliable and everything just works? Like, you have to have dedicated people to do the operation side, because if you're doing this on the cloud, people need to know, for example, Amazon or DigitalOcean, how these things work there. Otherwise, it will become a mess. And we said, hey, if we're doing microservices or services, we need to find something really simple. We don't need to use a full stack framework just to manage some sort of APIs. There's no need for that. And this was done. We used Zen Expressive with Tactician and dependency injection container from Symfony, and it works really fine. But one thing that was really, really important about these definitions was the fact that we said, hey, let's increase the level of the strictness of everything to the top. So when I'm saying this is, let's cover everything that makes sense with unit tests. Let's write integration tests. Let's use all the Gherkin scenarios that the POs are writing and automate that with Behat. Let's use phpstan with the maximum level, and we are doing that. Let's have functional tests, at least to cover if everything is working on the HTTP side with Postman. and automate all the things. We even added mutation tests with infection, which helped us to catch some edge cases inside of this unit test that we were not covering and everything. And to ensure that the code style is good, we decided to not only use PSR1 or PSR2, but rather Doctrine coding standard, which is amazing. As a team, we decided to do some small changes, like just remove a space from here or align something else there. But the strictness that Doctrine coding standards bring to the project was really cool. Like, you could see, like, all the developers were not complaining about the code style, the code style during the code review, but rather in using a tool to say, hey, don't do that, don't do that. You also simplify the code reviews on the pull requests. And one thing that was really, really important, we are growing and growing and growing. And we have clients all over the world. And everything is processed here in Europe. So we need to have some sort of structure that allows us to collect data from everywhere and process here without much delay or like trying to be near real time. And we found that, hey, we need to use this millions of users thing because everybody wants to be there and retrieve data. And Kafka was a project that we discovered and started to explore. Kafka is really amazing. It has many things or architectural decisions made on the basic foundation of it that simplifies many things. But it's also complicated to set it up. If you need a lot of resources and knowledge to do that. The basic structure of Kafka works with topics and brokers. So topics is like a channel where you're going to send the messages. And the brokers are storing these messages. To ensure that everything is distributed and scalable enough, Kafka does each broker gets assigned, or each partition of a topic gets assigned to a leader. So one of the brokers of your cluster will be the leader of the partition in this specific topic. And when you send messages to Kafka using the producers, these messages will say, hey, the broker, even though I'm not connected to the leader of this specific partition, the follower will replicate the message to the leader, and the other followers will just get the message again. So it doesn't matter if you're consuming from the leader or not, you will always have that specific message there. And if for some reason the leader dies, it is not functioning properly or anything else, a follower just gets promoted for that specific, for the partitions that the follower, the broker was the leader. One really, really important thing that we have to say about the architecture is Kafka only gives you the ordering, or only guarantees the ordering of the messages per partition of a single topic. So when you're producing something or sending messages to Kafka, you will say, hey, write to the topic, and if you need that message to be consumed in this specific order, you're going to send these messages to the same partition because they're related to something else. And one really amazing thing that Kafka has is the streaming API. The streaming API is just a consumer, which will get the message, but you can while retrieving the message, you can process something like modify the value or send the message to something else, and that something will modify the value of the message. And then you just say, okay, I did everything that I need to do, send to this specific topic now. So for us, Kafka was a really good decision to use. We started this process with the feedback collection part. The feedback collection consists essentially in how we collect, process, and make the feedback item available to our customers. We said, hey, let's create an endpoint. This will already unify the schema of a feedback item. And this will be an async endpoint. We're going to receive something and just toss it over to Kafka, and eventually this message will be processed. Then we started to be able to have this kind of things because all the metrics were built in the process. So we knew the throughput and how the median and the percentiles of each request, or all the requests we were dealing with, to validate if the things that we were writing are actually matching with the objectives that we defined. We also managed to, well, to have this vision of how many feedback items we have per channel. And, well, this is really interesting. But there, you can see that we have the amount of messages we're receiving per minute. It's not a lot, but still, it's interesting to get insights of how your application is behaving. So the way we did that and implemented that was kind of the same of the Strangler pattern, but without strangling anything. So we have every single feedback item being sent to different channels, as we said before. We created this endpoint. And we started to duplicate the items and send to the feedback collection API. This process was done using a lot of different tools like Lambda functions, because we're storing some data in S3 and using SQS to do things in the current application. And you can see here how things are behaving. We have duplications and the injections that are essentially tossing over to this new endpoint that was created. We defined that the process was then the message gets sent to a specific topic. Another service was created there, which will consolidate the message. At Usabilla, we have this thing of partial feedback. So you can send different messages or different parts of the form that you're just replying, and we need to consolidate everything together. In order to process that, we created a stream consumer. But this streaming consumer, to avoid this thing of having too much logic inside of a Kafka thing, we had in the feedback consolidation box, we had an API. That API was doing the logic, and which is essentially an RPC endpoint, and the streamer was calling that. So we had some steps to consolidate a feedback item. Like we validate if the feedback item has the correct data. If we append information there, we ensure that the output of that to topic B looks like what we defined as a consolidated item. And for every new message that we receive, we append data. So there's also persistency happen there so that we can always pass the latest state of the feedback item to the topic. Then we have the processing box, which is essentially the same as the consolidation, but with a different intent. The idea of the processing here is to say how these consolidated items will be incremented. So we have some translations, or we have auto-labeling being added, and screenshot generations. Everything happens there, and once we have the information, we pass to the next topic. This topic will then be listened and consumed by the thing that will index data to a specific Elasticsearch cluster and make things queryable. So there were a lot of lessons that we learned during this process. And although they seem very obvious, we need to talk about them. The first one is we need to respect the constraints. We need to understand that people are different. Just like Erin said, we have biases, we have many things that we need to just say, hey, okay, this is what we can do together, and let's try to achieve that. And by constraints, we're also talking about technical constraints and limitations that are related to knowledge. For example, for me, it's really obvious that doing domain exploration sessions, like everyone benefits from it. You will get knowledge shared. You will see how things behave. You understand how you're going to model this specific application. However, for some people, this was not valuable at all. They were saying, hey, I don't care about this event you're talking now. I don't see any value in that. And for me, it doesn't matter if the event is feedback collected or feedback anything else. I just want to show data to my to our customers. So this challenge of getting everyone together was really complicated, but it is still doable. However, because we had limited amount of time, we did it with a limited amount of people. So the knowledge that we created there was not shared across everyone. And this leads to problems. If you're creating a ubiquitous language, you have to really make everyone engage to that, so that people will say, hey, this makes sense, or this doesn't make sense. Let's change to this, something else that is more clear, and it will help us to achieve this and that and that. For us, we're still trying to adjust now, because we've made this mess, and now we have to onboard everyone. And probably a lot of things that we created will change. But due to the decisions that we made to create the process, like adding the metrics, raising the strictness, and having these discussions, this will help us to change and embrace the change with confidence, real confidence. Communication was, and I think it will be a problem for everyone. Some of the components that we were making, they were not really well communicated, which means that the message that we were publishing to Kafka had this payload, and someone else was expecting a different payload. And the design decisions of this, they were not existent, or we just said, hey, let's rush this because we need to deliver. This led to extra work. And a good thing that we can use to prevent these problems regarding message consumptions is doing contract testing. Martin Fowler has an excellent article about that. And if you read that, you will understand how we can ensure that the consumers are publishing the messages and the are consuming the messages according to their expectations, and the producers are producing the right messages. And for me, this was the most important part of all the things that we did. Like, we really need to have disciplined people. Discipline is something that we don't usually have, especially when we're dealing with some people that are really young in the field. They just want to build things. They want to get things done. But taking some time to analyze what you're doing and just thinking is really important, because otherwise we will just create again a problem with these bad design decisions. So instead of rushing because of the time constraint, you have to say, hey, okay, we have this, let's go through all the possibilities that we can do. What are the workarounds we can apply that will not bite us afterwards? How can we achieve these goals with the basic set of features that we have? So we need discipline. We need discipline every single time for every single software we write. I hope that this adventure that we did was valuable for you. This was my experience with this whole thing of extracting components and creating services. This is a challenge because essentially you have to understand that everything changes all the time. So let's embrace the change. And for most of people, this is not really what they like to do. And that's my message. Thank you very much. I think we have some time for questions. Okay.
Yeah, that's my question. Do you have any questions? No questions.
No questions.
Everything clear.
There.
Okay, just a second. We have a mic. Let me just check whether we have an assistant. Just raise your hand. Okay, in the middle. Catch.
Hello.
Hi.
Just wanted to thank for the great talk. My question is, why did you choose Kafka and not something else?
Kafka was chosen based on the fact that it was distributable. Like, if things just get removed, or if the broker dies, something else will just pick up the work, and things will work seamlessly, and the streaming API. So these were the big two reasons that we chose Kafka. More questions?
Any more questions? Okay. Just a second. Is it?
Is it? Yes.
Okay.
Specifically on discipline and such, how do you deal with scenarios where you have people that don't want to actually move on and join the new thing, I would say? And do you have scenarios where you need to actually kind of isolate or something like that?
That is an excellent question. We had this happening not on the development side, but rather the product side. So people some of the product owners, they were just saying, hey, I don't want this. So what we did there was essentially thanking them for being there on the session, but not inviting them for new exploration sessions so that we can move on. And then work in different ways. For example, providing them some guidance and books so they can see the value and not hold us back while already practicing the domain explorations.
Okay, more questions? Okay, we have it here. Just a second. One is called Speedy and the other one is Gonzalez. So
Okay, let's be quick. You mentioned metrics. Did you did some metrics before entering the whole process? And another question is about art of metrics. How did you decide what to measure? I think it's important to know what to measure and why to measure, to have some sensible measurements. Thank you.
So in the current application, we have no metrics at all. So we don't know how things are behaving properly. We have some basic monitoring, knowing like the server is up or down, right? But no application metric. To define how can we, or which metrics to choose or why they are relevant, we had a lot of talks with people from customer success and product to understand what is really important. For example, one of the metrics we have is how long should it take from sending a message, like the end user submitting a feedback form, and that information appearing in the customer, our customer's interface. Because we sell that as real time. So when that gets there, you will see that. But when you're having this many layers of queues and stuff, you have eventual consistency. So you cannot say it will it will be real time, because your queue could be filled up with many things. So there's no way to guarantee. We decided to measure that because that's actually something really important for the sales team as well. And we said that the objective is in about 30 seconds at most, the data should be there. And if it is not there, then we need to improve the things that we're doing. So remove some calls in the streaming process, for example, which now is doing many HTTP requests, like around 5 or 6. We can optimize that by removing this, because these calls are synchronous while consuming the message, right? So we try to be pragmatic when developing this, so that we could deliver the change without breaking anything, without making clients see that we are having this new experience, and also getting knowledge about that.
Okay, more questions? None. Okay, thank you, Luis.
Thank you very much.
Okay.
Enjoy the conference.